In this video, we're going to be taking a look at part B of the stoichiometry lesson, which is gravimetric stoichiometry. And that's where we're basically doing stoichiometry, but we have mass values given to us. And as you might remember, if you have a mass value given to you, you can't use mass ratios. So here's a great analogy that illustrates that. So let's say, for example, we're given a substance, its mass. So let's say substance A, we said we have so many grams of substance A. And we ask you, okay, well, how many grams of substance B will be produced? And so generally, if you were going to do that, if you had moles, you could do a mole to mole ratio. But if you're given grams, you can't go from grams to grams. There's no direct route there. It doesn't work that way. So what you need to do is you need to convert the grams of substance A into moles of substance A, because as you know, there's an equation that relates that. Moles is equal to mass over molar mass. And then use the mole ratio between A and B to find the moles of B. And then finally, once you have the moles of B, you can reconvert back to grams of B, and that gives you the mass there. So the general idea is to get somewhere, you need the mole ratio. If you're given something other than moles, convert to moles first, find what you need to find in moles, and then convert to where you need to go afterwards. So we're going to see some mass to mass stoichiometry, mole to mass stoichiometry, and essentially you just need to apply the formulas that we learned about previously. So the mass formulas or particle formulas, depending on what the question's asking. So we'll do a couple examples of these gravimetric stoichiometry problems. Again, that involves masses. Don't use mass ratios, convert them to moles first, and then do your mole ratios. So let's go ahead and try that out. Let's go over here. So we have aluminum reacts with sulfuric acid to make aluminum sulfate and hydrogen gas. How many moles of sulfuric acid would react with 2.98 moles of aluminum? So let's first of all write out a balanced equation. So we have aluminum, that's solid because it's a metal at room temperature is typically solid, reacting with sulfuric acid. So see, you need to know a lot of your unit 2 stuff where you have to make formulas. So sulfuric acid is H2SO4AQ, and they're going to make aluminum sulfate, so Al2SO4 and then some hydrogen gas, H2 gas, and I believe this is still aqueous. You can double check in your precipitate table to see if that's aqueous or solid, just to make sure. So when we do this, I believe it does stay aqueous. And then you have some hydrogen gas produced. We have a single displacement reaction. We need to make sure that it's balanced. And right now it doesn't look balanced to me. So I think I can put a 3 here, and that gives me 3 sulfates, but 6 hydrogen. So I need to put a 3 here, and then a 2 here. So 2, 3, 1, and 3. And now it's balanced. So 2 aluminums, 6 hydrogens, 3 sulfates, we're done there. And we want to know how many moles of sulfuric acid will react with 2.98 moles of aluminum. So let's go ahead and write down some information here. We have 2.98 moles of aluminum, 2.98 moles. And then we have, we want to figure out how much sulfuric acid would react in moles. So this is a nice mole-to-mole problem. There's nothing different or tricky here with that. So we can go ahead and just find our ratio between the aluminum and sulfuric acid. So we have 2 aluminums, 2 molecules or moles of aluminum for every 3 molecules or moles of SO4. And you could also write that as, for example, 2 aluminums for every 3 H2SO4, or you might write it the other way, 3 H2SO4 will react with 2 aluminums. That's the ratio we see there, and it's the most simplest. It's the simplest ratio. So now we can do our conversion factor. So we have our known moles, which is 2.98 moles of aluminum, so 2.98 moles of Al, multiplied by one of these conversion factors that gets rid of Al and keeps what we're looking for, the H2SO4. So that one there. So we're going to do 3H2SO4. I should say moles because we're dealing with moles right now. 3 moles of H2SO4, and this is aluminum Al, over 2 mole of Al. We can cross out moles of Al, right? And so now we're doing 2.98 times 3 divided by 2. So 2.98 times 3 divided by 2, and we get 4.47 moles of H2SO4. And that's 3 sig figs here, and then 3 sig figs over here as well. So that's good. And it's not really a measured value, so it doesn't matter too much, but we have 4.47 following the 3 sig figs there. And we can put a therefore statement next. So step 4, therefore 4.47 moles of H2SO4 react, or would react. So again, we followed our sig figs, 3 sig figs over here. And even though we're making this theoretical, let's just assume we measured that value, and so we're going to follow sig fig rules. So 4.47, and it works out. Remember, we don't count the coefficients because those are exact numbers. So now what we're going to do is we're going to take a look at the next question, which has a mass involved. So how many grams of aluminum sulfate would be produced from 50.5 grams of aluminum? So we have to do the first step is the same. First step is let's write out that balanced equation. We already did that from the previous question. H2SO4AQ, and then we have 1Al2SO4 3AQ, and then plus 3H2 gas. I do quickly want to verify just to see if the aluminum sulfate is soluble or not. I'm pretty sure it is, but just to double check. I mean, I could be wrong. So aluminum sulfate, it depends on how much water there's there, but so we have aluminum soluble. Okay, yeah, we're soluble. Good. Okay, just making sure. It's not a big deal. We really care about stoichiometry in this question mostly. So let's go ahead and write our information. So we want to know, we have a mass of 50.5 grams, and we want to know the mass of aluminum sulfate produced. How do I know that? Because it says how many grams of aluminum sulfate will be produced doing that. So under typical conditions, we could just do a mole to mole ratio, but we don't have the moles at this point. So what we're going to do is we're going to find the moles of aluminum. All we have to do is that the moles of aluminum is going to be equal to the mass of aluminum over the molar mass of aluminum. And the reason that is because, remember, I'm just going to put a little asterisk over here to show you why. The mass is equal to moles times molar mass. So moles is mass divided by molar mass. We just rearrange the equation there. So just showing you that work there. And so that's going to be equal to 50.5 grams over the molar mass, which is aluminum 26.98. 26.98. So 26.98 grams per mole. Don't multiply this molar mass by 2 there. You're only using those coefficients really for your mole ratio at the end. Don't multiply the molar mass by 2 just because you see a coefficient 2 there. Just treat it, it's the molar mass for aluminum, not for 2 aluminums. And we're using the mass there. Okay, so grams and grams cancel out. We get moles in the end. And so we get 50.5 divided by 26.98. So I'm going to keep more decimal places than I need because I just don't want to be too far off from the actual answer. So 1.8717568557 moles of Al. Okay. So in my step 3, I'm going to now make a mole ratio between what I have, the aluminum, and what I want to have, the aluminum sulfate. So it's essentially a 2-to-1 ratio. I have 2 aluminums for every 1 aluminum sulfate. And so knowing it's 2-to-1 ratio, you'd say, well, if I have 2 aluminums, I have one aluminum sulfate. So you divide by 2 essentially. And so you would already, just at a quick glance, know you can just take this number, moles of aluminum, and divide by 2. And that would give you your answer of aluminum sulfate. But let's go ahead and show that using our mole ratios. So I'm going to take the moles of aluminum, so 1.8717. I'm not going to write all the digits in, but you get the gist of what I'm doing there. Moles of aluminum. Multiply it by the ratio that will get rid of aluminum, which is essentially the ratio that would be 1 mole of aluminum sulfate for every 2 moles of aluminum. So you cancel aluminum out because you're divided by 2. You're doing 1.87 times 1 divided by 2, which is just divided by 2. So divided by 2 here, and we get 0.935878428 moles of H2SO4. Now we're not quite done yet. Now, I know I should have made more room here, so I'm just going to continue the problem down here, and we'll erase it after to go to example 6. But right now what I did is I found the moles of aluminum sulfate. And remember, to find the mass, you need moles times molar mass. So I found the moles of aluminum sulfate. So now to find the mass of aluminum sulfate, that's 2, that's a 3. I need to do the moles of aluminum sulfate multiplied by the molar mass of aluminum sulfate. So the molar mass, I'm just going to show you that over here. We can use our periodic table to find that. And so when you use your periodic table, we have 2 aluminums. So let's go to a periodic table here. 2 aluminums, which is right here. So 2 times 26.98 plus for sulfur we have 3 sulfurs. 3 times 32.07 plus how many oxygens? 12 oxygens, because there's 3 times 4 there, right? So 12 times 16. We have a molar mass of 342.17. So that's 342.17 grams per mole. And so we can just write that out here as 0.935878428 moles. You don't have to write all those digits down. I keep them all in my calculator though, just so I'm not far off from the from where the answer should be once I round. The more you round, the farther away you're going to be from your answer. So times 342.17 grams per mole. Moles cancel out, and in the end we get, so let's plug this into our calculator, 0.935878428 times 342.17. We get 320.2295217 grams of H2SO4. But don't forget, we have to follow the proper number of sig figs. So in our question, the number of sig figs provided, the only number provided is really 50.5. So this is 3 significant digits. So we need to round this to 3 significant digits. So that's approximately, so there's a few ways you can do it. We can get 320 grams of H2SO4, or you could have written this as, because 3 significant figures would have to include that 0, so you have to put a point there. Or you could write it as, so I'm going to put it up here, or 3.20 times 10 to the power of 2 grams in scientific notation. So either of these methods would have worked to get you 3 sig figs in the end. And then you can do your therefore statement. So therefore, 320 grams of H2SO4 could be produced. And so that there is your final answer when it comes to what mass could be produced. Notice that we had to first write out a balanced equation. We have to acknowledge that we started off with masses. We want to use somehow some data here to find the mass of aluminum sulfate produced because we're asked for grams here. Now we can't do a mass to mass ratio. We have to do a mole to mole ratio. So we can just convert the mass of the aluminum to moles. And then after that, it becomes a basic stoichiometry problem with mole to mole. We make a ratio 2 to 1. We use that ratio to find how many moles of H2SO4 are produced. And then we have to be careful because it asks for grams here. So now we can go and convert from moles to grams by simply doing the number of moles times the molar mass of the aluminum sulfate specifically. And we calculated that using the periodic table. And then afterwards, we put that in the formula there, crossed out our units. We got a final answer, and we made sure our final answer was to the correct number of sig figs, which is 3 sig figs, as you see over here, provided in the question. And in the next video, we're going to take a look at examples 6, 7, and 8.